All right, here we want to talk a little bit about conditional probability. So the probability of an event, given that another event has occurred, is called conditional probability. The conditional probability of A given B is written P and then A with that line going down and B, right? So that the way we read that is A given B. So the conditional probability of A given B is computed in the following way. We take the probability of the intersection of A and B and divide it by the probability of B. So there are other names for these. So the term in the numerator, the probability of the intersection of A and B, is called the joint probability. And the probability in the denominator, the probability of B, is called the marginal probability. So to give an example of that, then, we want to think about the probability of I am given that person is husband. So how do we find that? Well, we're going to take the joint probability, so that's the 278, and where I'm finding that is the joint frequency for husband and I am is 278, divided by 1010, and then take that value and divide it by the marginal probability of husband, which is 507 divided by 1010. Where the 507 is coming from is I take 278 plus 127 plus 102, and that gives me the 507. So you'll notice here, though, that I didn't write down the 1010. The 1010 appears in the numerator and in the denominator, and they cancel out. So I've just eliminated that step in there. So 278 divided by 507 is 0.5483. So that's the probability of the person responding I am, given that there's a husband. So similarly then, if we look at wife and my spouse, we want to find the probability that the person is the wife, given that they answered my spouse. We do something very similar, right? We find the joint probability of the person being wife and my spouse. So that's the 111. The 111 is divided by the 1010 to get the probability. But again, the way that I'm writing it up here is I know that the 1010 is going to appear in the numerator and the denominator, so I'm just canceling them out ahead of time. And so then I need the marginal probability of being my spouse. So where do I find that? I go to the my spouse entry here, and I've got 127 plus 111. I add those together to get 238. Again, you can pause the video and pull a calculator out to check that if you like, but the answer will be 238. So then I get 111 divided by 238, and I get an answer of 0.4663. And again, technically, you might have over here the 111 divided by 1010 and the 238 divided by 1010, but the 1010s will cancel out, and you'll get the same answer here. All right, now thinking about this conditional probability and the expression that we've had before, that it's just the joint probability divided by the marginal probability, we're assuming, of course, that that marginal probability is not zero, right? B can actually take place. Otherwise, this expression doesn't make sense. You can't divide by zero. But if we are using it, it's just a mathematical expression, and we can multiply that probability of B by both sides. So this is a multiplication law. So if we happen to be starting off with knowing the marginal probability and the conditional probability, we can find the joint probability. And that's given in this expression that you see here. So an example would be the probability of B is 0.4, probability A given B is 0.6, then the probability of the intersection is just the product of those two, so 0.4 times 0.6 is 0.24. Now here, what I'm showing is a joint probability table. So this is very similar to the table that we saw before, except that instead of the values in the table being expressed as frequencies, they're expressed as their relative frequencies or probabilities. The values inside the table, such as the 0.24, the 0.03, the 0.56, and the 0.17, those are called joint probabilities. While the values in the bottom row and the far right column with the headings total, so the values 0.8, 0.2, 0.27, and 0.73, those are what we call marginal probabilities, and they appear on the sides or margins. So, for example, in this setting, the probability of not being promoted is 0.73. Now, if we knew whether or not the person were a man or a woman, right, then we could make a different assessment of that, use a conditional probability. So, related to conditional probabilities, we want to think about some situation where the events are independent. That's another word we'll use here. So if the event, or if the probability of event A is not changed by the occurrence of event B, then we say that events A and B are independent. So if we've got two events, A and B, and the probability of A given B is equal to the probability of A, or the probability of B given A is equal to the probability of B, then the two events are independent. So, for example, just to illustrate this in a little setting here, A and B are independent. So what do we know then? The probability of A is 0.2 in this example. Probability of B is 0.3. Then the probability of A given B must be 0.2. So if we're following this through, some of the things that we've seen before, what does this imply? The probability of the intersection of A and B equals the probability of B times the probability of A given B. It must equal 0.06, and so on. Okay, so this is a case here where we can have two events and the conditional probability equals the marginal probability. Then in this case, the events are independent. So to give an example here of using this again using this concept of conditional probability, I want to think about the second bullet here. You can calculate the probability of a home selling in 31 to 90 days, because what we've got here in this table is we've got frequencies for how long it takes for a house to sell, given certain asking prices. So, for example, in the first row, we've got asking prices for the house that are less than $150,000, all the way out to, in the bottom row here, they're greater than $250,000. We've also got categories for how long it takes how long it takes for the house to sell. So anywhere from less than 30 days to greater than 90 days. So we can calculate the probability that something will sell within 30 to 90 days by simply looking at or adding up all of the homes that sell in that time frame and dividing that by the total number of homes in this example. And the answer gives us 0.625. But then if I want to find the conditional probability, so for example, I don't want to know just what's the probability that a house sells in 31 to 90 days, but I happen to know some information already, which is that the house was initially listed at, for the initial asking price, was between $150,000 and $199,000. So if I happen to know that, I can make a revision, I can make an adjustment. So I can calculate the conditional probability. And where do I get that? So what I've got here then is 150 over 250. Now, again, technically, you might want to divide the 150 by 800 and divide the 250 by 800 to get this, to calculate probabilities for the numerator and denominator. But I know ahead of time that the 800s are going to cancel out, the 800 again being the total number of observation in this experiment, in this survey. So I've just gotten rid of those 800. So the 150 in the numerator here is the joint probability of being 31 to 90 days and having an initial asking price of $150,000 to $199,000. So where do I see that? I've got the 31 to 90 days. I've got the $150,000 to $199,000. And where's their intersection? It's here at 150. And then I want to get the marginal probability of what? The marginal probability of being listed initially at $150,000 to $199,000. So what am I looking at there? I'm looking at this group here. It's the 20 plus 150 plus 80 equals this total over here of 250, and that's where this 250 up here in this equation is coming from. So take the 150 and divide it by 250 and I get 0.6. Again, if you prefer, you can go through the steps of dividing by 800, divide the numerator by 800, divide the denominator by 800, and then divide the numerator by the denominator to get the 0.6 as well. So now, give you just a moment to try this out. You can go ahead and pause this when you're ready to start working on it, and then start up again to check your answers. But you just want to find out some conditional probabilities as seen there in the bullets. So pause when you're ready to work, and then start up again to see the answers. All right, hopefully you found answers of 0.1 and 0.05.